Assalamualaikum and a very good day to my fellow listeners. This project is entitled Biodegradability of Cellulose Nanocrystal Thermoplastic Polyurethane Nanocomposite. The leader of this project is Dr. Khairatun Najwa binti Muhammad Amin, followed by me, Afkar Rabbani Hidayatullah, and my fellow innovator, Intan Shahira binti Azli. The fundamental of this project is basically the incorporation of cellulose nanocrystal, CNC, as the reinforcing agent to the base polymer matrix. In this case, that is TPU, thermoplastic polyurethane. This will result in the improvement of the mechanical properties of the CNC TPU nanocomposite and enhance the biodegradability of the material. There are a few problem statements that are found in this project. Firstly, is the dependence of mankind on fossil fuels. We have been relying on fossil fuels for too long now, and the amount of it will be used up one day. Hence, we want to reduce the usage of fossil fuels on the production of materials. In this case, a polymer that is TPU, thermoplastic polyurethane. With the use of filler, we can reduce the amount of TPU usage in our daily life. Next is the impact of the industrialization to our environment. It is an open secret that the production of materials to be used in our daily life affect our environment, and we need to reduce everything that causes global warming and therefore climate change. In my case, I will be reducing the usage of TPU in commercialization, in industrialization purposes by utilizing CNC as an additional material to be mixed with TPU. This will bring us to the third problem statement. The addition of CNC to TPU will result in the improvement of the mechanical properties of TPU. Hence, we can improve the quality of our product compared to pure TPU composites. Why we should consider using CNCs as a functional filler? There are three things that I want to highlight here to my fellow listeners. CNC is derived from its mother cells, cellulose, which can be found mainly in plants. This resulted in CNC can be considered a renewable material. In addition to that, CNC retain the color transparency of TPU compared to other fillers such as carbon and graphene that will change the color and transparency of TPU nanocomposites. Finally, it has good mechanical properties and be able to compete with the other reinforcing agent. The application of TPU is quite broad, from the production of power tool appliances, automotive field, and especially in the medical field, in the production of medical tubings and catheters. Our target consumer will be Bosch as the production of power tools appliances in the automotive field, that is Proton, and in the medical field, that is the Ministry of Health. The novelty of this project is the application of CNC as a reinforcing agent to improve the properties of thermoplastic polyurethane and enhance the biodegradability of nanocomposites.
As for methodology, CNC was prepared by phosphoric acid hydrolysis. The TPU and CNC are compounded through extrusion process by a twin screw extruder. The extruded then was pelletized and dried overnight at 70 degrees C. After that, a compression mold was carried out by using a hydraulic hot press machine at 190 degrees C.
So in order to study the biodegradability of CNC TPU nanocomposites, the samples are subjected to UV ultraviolet exposure with different duration of hours. As stated in the graph, pure TPU films that is subjected to 72 hours of ultraviolet light recorded the highest tensile strength. Meanwhile, the recorded tensile strength for CNC TPU nanocomposites for the same duration of hours is way lower than pure TPU samples, but experiencing increased elasticity of the nanocomposites. This will result in our product to be easily degradable compared to pure TPU films.